and bring the urine sample. So one volunteer, please, bring the urine sample. Any one person should go and bring the urine sample.
واحد يتبرع.
Anyone.
ردادي. تفضل ردادي.
Hurry up, one person.
One person.
Lazim bring the urine, otherwise how to perform?
انتبه يورين ها.
Okay. Now in today's exercise, we will see how to analyze some other chemical components of the urine sample, and these include number one, creatinine. Number two, calcium. Number three, ketones. And number four, urea. So four things we will detect today. Number one, creatinine. Number two, calcium. Number three, ketones. And number four, urea. Now, out of these, if we talk about creatinine, creatinine is one of the normal components of the urine, and it is specific in the character that all creatinine that is formed, that is filtered out, it will be totally excreted out. There will be zero reabsorption of creatinine. So creatinine is different from other substances in the character that whatever the creatinine is filtered out, it will totally excreted out without reabsorption of a single part of this creatinine. So you can say that the reabsorption of creatinine is zero, and whatever it is filtered out, it is expelled out. This is the reason why creatinine is considered to be a very, very important diagnostic tool for the assessment of renal function. And all those cases where creatinine is found to be less than normal in the urine, it indicates some loss of kidney function. So that's why creatinine is very important. And the amount of creatinine which is excreted out, it depends upon the muscle mass of the body. It varies from muscle mass of the body. because it is obtained from a substance called creatine, and creatine is obtained from the muscles. Now, how to determine the creatinine? In order to determine creatinine in the urine, we need, number one, about 3 to 5 ml of urine. Take 3 to 5 ml of urine sample for creatine. Then to this sample, you add 1 ml sodium nitroprusside. 1 ml sodium nitroprusside. Addition of sodium nitroprusside will make the color of the urine orangish, orange-like color, or you can say bright orange-like color. Then after this color develops, now you add few drops of 10% sodium hydroxide. Few drops to 1 ml. Take 1 ml and add drop wise. If the color of your solution, your sample, changes from bright orange to yellow color on addition of sodium hydroxide, it means that creatinine is present. So a change of color from bright orange color to yellowish color on addition of 10% sodium hydroxide, it indicates that creatinine is present. So what you take? First you take 3 to 5 ml of urine sample, and to it add 1 ml sodium nitroprusside. What will happen? The color will become bright orange color. Bright orange color. After developing the bright orange color, now you add few drops of 10% sodium hydroxide. If the color changes to yellow, it means creatinine is present. Okay? Number 2, second part is to determine calcium in the urine. In order to determine calcium in the urine, we need a specific reagent. Like for
Benedict.
glucose, you use Benedict's. Similarly, for calcium, there is a specific reagent called Sulcovic's reagent. Sulcovic's. So you take Sulcovic's reagent, and what you have to do, that in 3 ml of urine sample, add equal volume of Sulcovic's reagent. So reduce the quantity. Don't take 3 ml of urine sample, take 2 ml of urine sample. And equal volume, that is 2 ml of Sulcovic's reagent in it. Mix it properly and wait for 2 to 3 minutes. If after 2-3 minutes you found a precipitate, it means calcium is present, because if the calcium will be there in urine sample, it will combine with oxalate part of Sulcovic's reagent to form calcium oxalate crystals. Calcium from the urine combined with oxalate part of Sulcovic's reagent and will form calcium oxalate crystals. Remember, calcium oxalate crystals. Just like what you formed in the chloride detection, silver chloride. Silver from the silver nitrate and chloride from the urine, forming silver chloride. Similarly, here calcium from the urine and oxalate from the Sulcovic's reagent combine to form calcium oxalate crystals, which will settle down to form a precipitate. But here in this case, the point to remember is that the formation of calcium oxalate crystals, it will depend upon the concentration of calcium in the urine. We are taking very small quantity, 2 ml urine only. So the 2 ml, if a normal sample usually does not contain too much calcium. Therefore, the precipitate which will be formed will be very thin precipitate, not thick just like chloride. So a thin precipitate will be formed in a normal sample. But a person who has tendency to pass calcium, or if you collect the urine sample of a postmenopausal woman, 50 years, 60 years female, then it will contain more calcium and the precipitate will be thick. Otherwise it will be a thin precipitate. So 2 ml urine sample plus equal volume of Sulcovic's reagent, after 2-3 minutes, if you found a precipitate of calcium oxalate, then it means that calcium is present. Thirdly, you have to detect another thing which is called the ketones. Which is called ketones. The ketone bodies which are found in the urine, and normally they are not, but in a person like diabetic, you will find ketone bodies because of the breakdown of fat particles. Now the ketone bodies, if found in the urine, we can detect them by the help of another substance which is available in a powder form, not liquid, not solution. And this powder is given the name Dum and Shipley powder. D-U-M-M, Dum and Shipley. Two scientists, Dum and Shipley, they together work to develop this powder. Therefore, it is given the name Dum and Shipley powder. So we need this Dum and Shipley powder to determine the presence of ketones in the urine sample. How to determine it? For this purpose, first you have to take a filter paper. A filter paper. And in the center of the filter paper, you make a circle. Okay?
By pen or?
No, by pen, pencil, anything. Now in this circle, not necessarily, if you want to made it, if you don't want, don't. But better to make a circle. In this circle, you put Dum and Shipley powder by taking with a pinch, a small quantity. Not too much is required, just with a pinch. You take a small quantity and few pieces of this Dum and Shipley powder. Now with the help of a dropper, you take your urine sample and put 2-3 drops of urine sample on this Dum and Shipley powder. If after putting urine on Dum and Shipley powder, if the appearance develops like this, purplish appearance, a purple color develops, it means that ketones are present. It means the urine contains ketones. But if the ketones are absent, no ketones in the urine, then after adding urine sample on the Dum and Shipley powder, there will be no color change like this. No color change. The urine will remain as it is. No color change. So after adding few drops of urine on Dum and Shipley powder, if you will observe no color change, it means ketones are absent. But if after adding urine sample, you observe a purplish color change, it means ketones are present. This was the third point. Then number 4, how to determine urea in the urine. In order to find out urea in the urine sample, you take a clean slide. A clean slide. On this clean slide, take 2 drops of urine sample. Or if large, 1 drop is enough. But if the drop is small, 2 drops you can take. Now to this 1 or 2 drops of the urine sample, add 1 drop of concentrated nitric acid, HNO3. So on a clean slide, take 1 or 2 drops of urine sample, then to it add 1 drop of concentrated nitric acid, and then put a cover slip over it. After putting the cover slip, what you do, that on a flame of burner, just pass this part, the urine containing part of the slide, 1 time like this and 1 time like this. So only 2 times. Suppose this is the flame, so 1 time pass like this, 2nd time like this. Just to warm the slide, so that a reaction will take place. After this, wait for 1 or 2 minutes for the slide to cool down, and once it is cooled down, you focus the slide on the microscope and look for the urea crystals. The urea crystals, they will appear as hexagonal shape structure. hexagonal shape structure. Just like the shape of the cheek cell that you observe in first year. Cheek cell you observe?
Yes, yes.
Hexagonal in shape. Similarly, hexagonal shape will appear on the urea crystals. So, when you found in your slide, if you observe hexagonal shape structures there, it means urea is present. And naturally, a normal urine sample must contain urea because it is the basic nitrogenous waste material to be expelled out. So, observe your slide under the microscope after preparing. So, 4 things you have to do today. Number 1, creatinine. How? Taking about 3 to 5 ml of urine sample
1 ml.
plus 1 ml of sodium nitrochloride. Mix it, see the color, a bright orange color will be there. Then add drop-wise 10% sodium hydroxide. If the color is changed to yellowish, it means creatinine is there. Number 2, calcium, 2 ml urine sample plus 2 ml Sulcovix reagent, equal volume. Mix it. Wait for 2-3 minutes for the precipitate to form. Calcium oxalate crystals will settle down to form precipitate, which shows presence of calcium. If no precipitate, calcium absent. Thirdly, ketone bodies. Take a filter paper. In the center, make a small circle. Put a pinch of Dum and Shipley powder and 2-3 drops of urine sample over it. If the color is changed to purple, it means ketones present. If the color is not changed to purple, it means ketones absent. Number 4, urea. Take a clean slide, put 1 or 2 drops of urine sample over it, then 1 drop of concentrated nitric acid over it, put a cover slip, warm it by passing 2 times over the flame of the burner, then let it cool and then focus under the microscope. If you found hexagonal shape urea crystals, it means urea present. If you will not found, urea absent.
How many nitric acid?
1 drop.
And 2 drop urine.
2 drop urine if small drop. If large drop, 1 drop is enough. Okay? So these 4 things you have to do today. On the back bench, the things are there. See the things there, take them.